Hello students, welcome to Skill Area 7.0 of the Food Microbiology module, which is Identify Food Preservation Methods to Control Microbial Growth. What is food preservation? It is the process of treating and handling food to reduce food spoilage or prevent foodborne illness while maintaining nutritional value, texture, and flavor. The 4 food preservation strategies are reducing excess, physical removal, preventing growth, and killing of microorganisms. Below are the common food preservation methods that is used in industry, which are heat, low temperature, using preservatives, and atmospheric adjustment. Using heat in the food preservation. There are 3 common heat treatments for food preservation that are used in the food industry. They are pasteurization, UHT, and botulinum cook. In pasteurization, there are 2 main processes, which are LT, which stands for low temperature long time, which is 63 degrees Celsius for 30 minutes. And HTST, which is high temperature short time, at 70 degrees Celsius for 15 seconds. Even though the process can kill all pathogens, some spores can still survive, therefore the food still needs refrigeration. UHT stands for ultra high temperature treatment at 150 degrees Celsius for 2 to 3 seconds. This process will kill all pathogens and spoilage bacteria, and therefore you can store the food under room temperature without problem. Botulinum cook. Botulinum cook is a high heat cook at minimum temperature of 121 degrees Celsius for at least 3 minutes in order to reduce the chance of survival of Clostridium botulinum spores. How does heat preserve food? Heat damages the bacterial cell membrane, enzyme, and DNA, making them unable to grow properly. Low temperature in food preservation. There are 2 common processes that uses low temperature, which are refrigeration and freezing. In refrigeration, the temperature is above freezing point, and the storage temperature is usually between 4 to 7 degrees Celsius, and it can actually slow down microbial growth. However, shelf life of food is limited. In freezing, the temperature is below freezing point. Storage temperature is usually between minus 12 to minus 18 degrees Celsius. Freezing can stop microbial growth, and therefore long shelf life of the food. The effect of low temperature on bacteria is that it can cause cold shock the bacteria and decrease their metabolic activity. Using food preservative. There are 2 classes of preservative commonly used in industry, which are unregulated and regulated. Under unregulated, there are salt, sugar, spices, and oil, while regulated are nitrates, sulfites, organic acids, and bacteriocins. Salt and sugar. Salt is mainly used to preserve vegetables, meat, and fish, whereas sugar is mainly used to preserve fruits in the form of jams. The advantages of using these 2 ingredients are they are cheap, abundant, and easy to find. The disadvantages are they can be very unhealthy, and some may be ineffective against salt-tolerant bacteria. Salt and sugar prevent bacterial growth by an osmotic effect causing plasmolysis of bacterial cells. First, water moves out of bacterial cells into salt or sugar solution. Secondly, bacterial cells become dehydrated and shrink, and therefore they are called plasmolyzed. And finally, the bacteria cells die. Nitrites and nitrates. They are common additive in meat curing. They are very effective against pathogenic bacteria, example Salmonella and Clostridium. The mechanism of preservation are it inhibits microbial growth by reacting with iron components of bacterial cells. Sulfites or sulfur dioxide, commonly used in soft fruits, fruit juices, sausages, and wines, effective against insects, bacteria, yeast, and mold. The mechanism? They react with proteins and enzymes of bacterial cells to reduce their metabolic activity. Organic acids can be naturally present in food or added externally or produced by bacteria. They are effective against bacteria, especially neutrophile and alkalophile. And their mechanism of preservation is that they interfere with cell wall, cell membrane, and metabolic activity of bacteria. What are bacteriocins? They are small proteins produced by many bacterial genera which can inhibit the growth of other bacteria. There are two main types of bacteriocin, which are pediocin and nisin. Pediocin is effective against a broad range of bacteria, and they dissolve membrane of bacteria. Nisin is very effective against gram-positive bacteria. However, it is ineffective against gram-negative bacteria, yeast, and mold. Their mechanism, they drill into bacterial cell membranes, resulting in the leakage of bacteria essential components. Bacteriophage are viruses that infect bacteria and replicate inside them, causing the death of the bacteria. The advantages are they only target specific food bacteria, effective against most bacteria, and only need small amount added to food. However, research costs for bacteriophage is really expensive, and some bacteria may develop immunity. That is the end of Skill Area 7.0. Thank you very much.